All right. Well, we've spent the previous 9 weeks worrying about things at the level of propositions. Propositional logic. You probably didn't think you had that much more to learn about propositional logic. It turns out it's really complicated if you just go substructural. All sorts of things that run together aren't anymore. But we haven't worried about anything below the level of sentences. We saw how to do logic with them. We saw how to characterize the conceptual content of them in precise terms and implication space semantics. But we haven't tried to delve below the level of sentences. And here, people who start their semantic thinking with the idea of inference, inferentialists, have a problem that people who are representationalists don't have. And that is to make sense of the idea of subsentential content. Nothing less than a sentence, sort of by definition, can be the premise or the conclusion of an inference. Indeed, that's how we pick out sentences and inferences are together. But what do you even mean by talking about subsentential expressions if you mean semantically significant subsentential expressions? I mean, we can make sense of the sentences being strings of symbols, but that's thinking of the symbols as like letters, not like words. The words are supposed to make a contribution to what the sentence means. And clearly the idea in some sense has got to be that the occurrence of this word in 2 different sentences is semantically significant insofar as it's making a contribution to the inferential role of the sentences in which they occur. But how can you make any more sense of it than that? So what I want to present today is one of my favorite arguments. It's epitomized on your handout. It's a simple 30-step argument. It's a paradigm, I think, of sort of consecutive thinking, but it is an extended train of thought. I've said from the beginning, a pragmatist approach says that semantics has to answer to pragmatics. The trouble is the pragmatics is all at the sentential level. The use of expressions that we understand is all at the sentential level. So, what are we going to do? Well, the subsentential structure that we know how to do logic with is first order subject predicate term and predicate logic. What does the tradition tell us singular terms are? Singular terms are expressions that refer to, denote, or designate objects. That's the thought with which representational semantics begins. We had to answer a question about sentences. What is it to use something as a sentence? We did that in terms of assertion, inference, giving and asking for reasons, challenging and defending. What is it to use something as a singular term? If you start off with that notion as your semantic primitive, you have to make sense of it as referring to, denoting, or designating particular objects. So from one point of view, that's what singular terms are. They pick out objects, at least when all's working well. Particulars, I'll just say objects loosely. You've seen there's other particulars, events, processes, but the particularity is the point. The predicates pick out properties and relations. Why do you have any? Well, because the world has particulars in it, and they have properties, and they stand in relations. That I take it is the standard order of explanation. But we could ask whether we actually can understand what we are saying when we say that the world consists of particulars and their properties and relations. If we don't understand what it is to use something as a singular term or as a predicate, as well as a sentence. In particular, this matters when we're wondering whether something is an object. So when Frege in the Grundlagen asks, are numbers objects, he immediately addresses that by asking whether numerals are proper singular terms. And his argument is that if we followed all the rules for introducing genuine singular terms in introducing the numerals, then there isn't any question of whether they refer to objects. The question is just what kind of objects they refer to. He's going to see every properly functioning singular term, Eigenname, he says proper name, but he's using it not just to mean proper names, but to mean singular terms more generally. Everyone, if it's been properly introduced, picks out some object, well, or possibly none, but that's a definite reference as well. Quine introduces singular terms in word and object as expressions that purport to refer to just one object. And then he's quick to say, but this notion of purport, that's just a colorful way, a picturesque way, he says, of alluding to the distinctive grammatical role that singular terms play in sentences. By playing the role they play in sentences, singular terms purport to refer to objects. And that tells us what we want to know. We want to know what is the grammatical role that singular terms play in sentences, in virtue of which it's proper to describe them as purporting to refer to particulars. And here, I think, I want to say that no one before Frege had an adequate answer to that question. What is it to use an expression as a singular term? What grammatical role do singular terms play? And that's because before Frege, people had an extremely attenuated notion of what a property was, and so of what a relation is. They didn't distinguish, as Frege taught us to do, between what Dummett calls simple predicates and complex predicates. Simple predicates are the expressions that you use concatenated with other expressions, singular terms, in order to produce sentences. So in another in a logistical syntax, we have the capital P that we can combine with two singular terms to get PAB. Maybe that's standing for A admiring B. So we say Kant admired Rousseau. We could write that PAB. The P is a simple predicate. The admired is a simple predicate. But here's the thing. If you look at the sentences, Rousseau admired Rousseau, certainly true. Kant admired Rousseau, definitely true. Kant admired Kant, well, he doesn't go on about that, but we can imagine that that's true as well. But the first and third of those sentences, Rousseau admired Rousseau and Kant admired Kant, there's no part of those sentences that they have in common with each other that they don't have in common with Kant admired Rousseau. There's just the admired, with, as it were, two spaces on either side. But there is a sense in which Rousseau admired Rousseau and Kant admired Kant ascribe a different property to Rousseau and Kant than is attributed to either of them by a sentence like Rousseau admires Kant, or Kant admires Rousseau. Being a self-admirer is a different property from being an admirer of someone or other, or being admired by someone or other. But how are we to think about that property? It's not captured by the simple predicate, which is common to all of those uses. A complex predicate keeps track of the cross-referencing of the singular terms that occur in it. You need to see that because if you want to understand the inferential difference that those predicates can make, different things could follow from being a self-admirer than from being an admirer. You know, maybe if you're a self-admirer, it follows you're vain, whereas just admiring someone, it doesn't follow that you're vain. And if you want to understand the difference between the inferences from anyone who admires himself admires someone, that's true. Anyone who admires someone admires himself, no, that doesn't follow. Well, why not? Well, you have to distinguish the complex predicates that are in them. And somehow you have to keep track of the inferential difference that the difference between different complex predicates corresponding to the same simple predicate can make. And it's against that background, I think, that we can appreciate the magnitude of Frege's conceptual and technical achievement in the Begriffsschrift. He saw that in order to express all of these new properties and relations, the complex ones, we needed to think about the syntax differently and the semantics differently. The basic syntactic operation pre-Frege, and you'll see this in people like Boole who were doing formal logic, mathematized logic as well. The principal syntactic operation was concatenation. You strung some symbols together. They were symbols of different kinds, and there were rules. The predicate comes with an adicity. It's monadic or dyadic, polyadic. It takes a definite number of arguments, so you had to put the right number of arguments in there. But you could build up the sentences from predicates and singular terms, combine them using sentential connectives, conditional, conjunction, and so on. And in simple sentence-only logic, we just need to know how to compute the inferential role of the resulting compound sentence from the inferential roles of the components that are in it. But Frege saw that in order to so much as syntactically generate the full range of complex predicates, we need an operation that doesn't put linguistic items together, but takes them apart. And he called this forming functions. You form functions, he said, by taking an object, a syntactic object, and taking something away from it, putting a hole in it, he said, which gives you a function, because if you put different things back into that hole, you get different objects back out of it. He saw that in order to express, even syntactically, the full range of complex predicates, you had to think of constructing sentences as as a two-phase process where you repeated a process of putting expressions together and then a process of forming functions from them. But those two phases could be alternated. You'd put something together, form a function from it, and then put it together with something else and form a function from that, and so on. You can think about this. We could start with P.A.B., Kant admired Rousseau, and R.A.C. R is having written, so Kant also wrote the Critique of Pure Reason. So we've got P.A.B. and R.A.C., and now we can go through and take the A out of both of those, put in a variable, and we have a property of the property that you have if you admire Rousseau and wrote the Critique of Pure Reason. I think, well, that's only Kant who did that. But then we can take that and use that as the antecedent of a conditional. We say if something has that property, then some other thing. Clamp a quantifier on to that first sentence. Say, well, someone, there is someone who both admired Rousseau and wrote the Critique of Pure Reason. Now we can say, well, if there is someone who did that, then possibly they did this other thing. But now we can go in and replace the Critique of Pure Reason, and if it occurs in the other sentence, replace it, form another function. Okay, some technical business to make this syntactic process work that has the synthetic phase of it when you put expressions together, and then the analytic phase when you take some bits out systematically and maybe clamp a quantifier on to bind those. But think about it semantically. He needed to keep control over what followed from the result of produce. If you take some object and you have an inferential role for it, so some stuff follows, some stuff is incompatible with it, we know how in the building phase to compute the inferential role of, say, conditionals that have that as an antecedent. We can build those to the sky purely at the sentential level. But now, how are we to understand semantically what happens in the second phase when you form a function to make this new property, the property of having admired Rousseau and written the Critique of Pure Reason, this new property, which we can put a quantifier on and say someone did that, did both those things. But now how do we compute the inferential role of that claim from the inferential roles of the sentences that we started with? And if we take that claim now and use it as the antecedent of a conditional, connecting it to a sentence that contains one of the remaining terms that was in this, and pull that out, so there is someone who admired Rousseau and wrote some book, and that book went on to be famous, we say. Now that's a property, and we can say, and there is some such book, too. Put the quantifier on that. Frege figured out rules that would compute as you build up and analyze down, that would at every phase say what the effect on the inferences was of making that syntactic move. And as a result, could take, at the end of the day, some incredibly complicated statement that has iterated alternating quantifiers in various places, widest scope and at various places inside, and could systematically compute the inferential role of that arbitrarily complex sentence by deconstructing it, strip off the outside operator and say what difference that outside operator made to the inferences, strip off the next one, say what that did, and eventually get so that you could compute the inferential role of that arbitrarily complex sentence. It's astonishing that someone could do this. All the more in that he had to introduce new logical vocabulary, familiar vocabulary, but giving it a new technical use, to codify those inferences, to codify the inferential significance that the occurrence of a singular term has in a sentence. You need to introduce identity locutions so that you can say T equals is identical to T prime. Benjamin Franklin is the inventor of bifocals. And to codify the inferential significance of a complex predicate occurring in it, you need quantified conditionals. The quantifiers that are generalizations of conjunction and disjunction. So he shows how to introduce these logical expressions as making explicit the inferential relations among complex predicates and singular terms, and does this in a way that is expressively complete. Of course, there's a sense in which first-order logic with identity is not complete, but you can codify all of these inferences with it. Well, that's what we need to reconstruct in inferentialist terms, is that Friggian achievement, so that we can discern subsentential structure in sentences and introduce logical vocabulary that will let us make explicit the contributions that those subsentential expressions make to the inferential roles of sentences that involve them. So I'm going to talk about this recreating the Friggian triumph in two steps, one this week and one next week. This one I think works. The one next week only sort of works. We're getting to the bleeding edge at that point. But what's required is to understand mostly this second operation, the formation of functions, because that's what complex predicates are for Frege. They're functions which give you sentences when you apply them to ordered tuples of objects. So Frege's basic idea was substitution, that he used the Bolzano method. We don't know whether he learned it from Bolzano because nobody read Bolzano in Germany in the second half of the 19th century, but Bolzano had this idea of noting invariance under substitution. Substitute one expression for another and see what remains the same, what properties of the object are and are not changed. And we care about sentential properties. So for Frege, he was looking at substitutions that saved truth value, saved the truth value truth-preserving substitutions. Substitutions salva veritate is what he was looking at. We have a richer notion of sentential content as inferential role, as codified in implication-space semantics. So we would be looking at noting invariance of various inferential properties under substitution, looking at substitution salva consequentiae instead of salva veritate. So we're going to give a very different kind of answer to the question, what is a singular term and what is a complex predicate now, than we do as an answer to the question, what's a sentence? For the sentence, we have a pragmatic story to tell about the use of sentences to make claims that are inferentially articulated. But we're going to use a substitutional scalpel to dissect sentences into singular terms and predicates, and those can count as semantically significant subsentential expressions insofar as we can say what difference the appearance of those subsentential expressions makes, what contribution it makes to the inferential role of the sentences in which they appear. So I want to talk about substitution under two headings, the syntax first and the semantics next. And I want to do this in as broad, abstract, and non-committal terms as possible. Noting invariance under substitution. Our notion of syntax, of subsentential syntax, already has that character. If you take some sentence that's a well-formed sentence and take some semantically significant part of it and substitute something else for it, one question you can ask is, well, do you get a sentence when you do that? Some substitutions of words for words will preserve the sentencehood of a sentence, and others won't. And your basic syntactic method of classifying subsentential expressions is to form equivalence classes of them where two things go in the same equivalence class if substituting one for the other in a well-formed sentence always preserves the well-formedness of the sentence, never turns a well-formed sentence into one that isn't. That's a way of getting a distinction between singular terms and simple predicates, for instance. You can do a first approximation, substitute terms for terms, and what you get may be nonsensical, but it'll be, in a broad enough sense, grammatical. But substitute a term for a simple predicate or vice versa, and you're just getting a string of words. So we can see that already at a purely syntactic level, how grammatical categories or syntactic categories of expression can be discerned by this Bolzano notion of noting invariance under substitution. But if we think about it in the most abstract terms, there's three general kinds of role with respect to substitutions that expressions can play. And you can see it if I say in the logistical, along this dimension, perspicuous syntax, I say P of AB, and now you can substitute C for B in that. I'm thinking the ABC is lowercase. You can substitute the C for the B and you get PAC. That's still a well-formed sentence. Well, there's the expression that you substituted in, the sentence that you started with. That's one functional role with respect to substitution that an expression can play. It can be substituted in. And our thought is, well, we already have some of those. Those are the sentences that we have been talking about all along. But what's new is the other two things. There's what's substituted for. I took PAB and substituted a C for a B in it to get PAC. B was substituted for. We could go the other way, say C was substituted for as well. That's playing a different role than PABC. PAB is playing. The whole sentence is substituted in. The singular term is substituted for. And there's the remainder, the frame of the sentence. What we could write as PA and then put some variable in there or some placeholder to mark the thing that we were substituting, the place where we were substituting things for things in it. Those substitution frames or remainders are not parts of the sentence in the sense in which what's substituted for is a part of the sentence. And you can see that if we go back to the case of Rousseau admiring Rousseau and Kant admiring Rousseau. We can get from Rousseau admired Rousseau to Kant admired Kant by substituting uniformly Kant for Rousseau. We've got to distinguish that sentence frame, the one where you can only substitute the same thing on both sides. We've got to distinguish that sentence frame from the sentence frame that has different things on both sides. That is, these sentence frames or remainders after substitution, these equivalence classes of sentences where each one can be turned into another one by substitution. That's the sentence frame or remainder. Anyway, that's what it has to determine. It's not a part of any one of the sentences in the way the simple predicate is. As I say, there's no part that's common to Kant admired Kant and Rousseau admired Rousseau that they don't have in common with Kant admired Rousseau, and yet there is a one place predicate that they share, that they don't share with the third element. These sentence frames or remainders, what corresponds to complex predicates, they're like patterns in sentences that are shared by them rather than parts of them. Parts can be patterns, but some patterns don't correspond to parts. And here by pattern I mean that PAA and PBB share the pattern that it's the same term that occurs in both places, and that's what PAB does not. Frege called these functions and engages in uncharacteristic, and it's clearly he's uncomfortable with these metaphysical extravagances, but he does engage, he does indulge in them a little bit in thinking about what bizarre kinds of things these functions are, objects that have holes in them that permit some fillers and not other fillers, and which we can poke more holes in, or which we can fill those up with quantifiers and combine them in various ways. But an absolutely, well, I wouldn't say absolutely unproblematic, a much less problematic way of thinking about them is just as equivalence classes of sentences that can be turned into each other by substitutional transformations. But we've got these three kinds of functional roles. I'll call them substitution structural roles that things can play. Because they're roles with respect to substitution operations, so your role with respect to that can be to substitute in, and we can actually understand all these at the purely sentential level. You can substitute in a conditional, substitute one sentence for a different sentence for the antecedent. Then what's substituted for is a sentence. What's substituted in is the conditional. And the substitution frame you get is that conditional with an open antecedent, but a fixed consequent. So I take the sentence, if the sign is octagonal, then the sign is a stop sign. And I can substitute something else for if the sign is octagonal. I can substitute if the sign is triangular. And now we can say, well, the sentence frame that remains is if, and then some placeholding variable, the whole in it, then it's a stop sign. And that's true when applied to the sign is octagonal, and it's false if applied to the sign is triangular. So we can see all these substitution structural roles, even just at the sentential level. We're talking about keeping the substituted ins just as being sentences. Eventually, we'll want to allow that you can substitute in terms as well, because you can build them up in complex ways. Trying to think of the rhyme of the, well, anyway. We can have complex terms and we can substitute in them too. So, eventually we'd want what's substituted in not just to be sentences, but also to be terms, but that's on down the line. Okay, so what's substituted in, what's substituted for, and then the equivalence classes of substituted ins that you get if you look at all the possible substituted fors that you can get with them. That's the pattern, the function, the complex predicate. And then if we think about our expressions, in order to understand semantically significant subsentential expressions, we need to understand what substitution structural roles singular terms and predicates play, and it's clear that what's substituted in is sentences, what's substituted for is singular terms, and the sentence frames that remain from that, the equivalence classes of substitutional variant sentences, those are the complex predicates. So that's maybe not very enlightening, but it's very abstract, and so very general. What about the semantics that goes with that? Well, there's a distinctive kind of inference that goes with substitution. Substitution inferences. Benjamin Franklin invented bifocals, but Benjamin Franklin is the first Postmaster General, so the first Postmaster General invented bifocals. Now, the identity is serving as an inference license that takes us from Benjamin Franklin invented bifocals to the first Postmaster General invented bifocals. We can think about that inference as a one premise, one conclusion inference when we later on introduce identity locutions as logical locutions. That'll be to make explicit our endorsement of a pattern of substitution inferences in which you can put the first Postmaster General into any position in which you can put Benjamin Franklin. But we could also substitute for the simple predicate. I'd rather call that sort of replacing the predicate. But we could go from Benjamin Franklin spoke English to Benjamin Franklin spoke French. We're thinking of the whole spoke English to spoke French as replacing one portion of the sentence, the predicate, with another, the simple predicate. There's an analog. There will be an analog for the complex predicates, but it's easier to think about replacement of the predicates at the simple level. So the notion of a substitution inference sort of makes sense for both singular terms and predicates. Is there any difference between them? At the semantic level, can we see any systematic difference between replacing a singular term with another and replacing a predicate with another? And here there's a striking thing. Singular term substitution inferences are always symmetrical. If you can go from Benjamin Franklin invented bifocals to the first Postmaster General invented bifocals, then you can go from the first Postmaster General invented bifocals to Benjamin Franklin invented bifocals. If the one substitution preserves, in this case, truth, but if the one is a good implication, then the other is. That's how we're going to get our edge in there inferentially later on. So we can either think of what we're preserving as the truth or the goodness of an implication. But the point is, singular terms, it's de jure symmetrical. And this is marked by the logical expression we use to make it explicit being an identity claim, which is certainly an equivalence relation. And that's not true of replacing one predicate with another. Thera walks, so Thera moves. That's a good implication, but not if you flip it around. Thera might move exclusively by flying or by swimming. It doesn't follow that Thera walks just because she moves. Maybe she just vibrates. Now, there could be symmetric intersubstitution relations among predicates. When people were really worried about this sort of thing in doing ordinary language philosophy, they worried whether there were actually any semantically equivalent predicates, where they're genuinely synonymous predicates, such that substituting one for the other never changed the truth value of a sentence they were involved with. And the suggestion was, yes, in English, the word furze, F-U-R-Z-E, and gorse, G-O-R-S-E, mean exactly the same thing. They're two Scottish words for this heath plant that there is, and there happen to be two words for it. But people sort of gave up looking after that because it wasn't worth fighting over that one example. But there could be, and particularly if we're talking about primary occurrences of the singular terms, so we're only looking at extensional contexts, well, there are lots of co-extensional predicates. Yeah, John.
So I'm wondering about the claim that substitution for singular terms is always symmetric. So I can infer from Thera was born before 1900 to Thera's mother was born before 1900, but not vice versa, right?
Right. In that context you can, but look at the context is older than Thera. It's true that her mother is older than Thera, not true that Thera is. So we can't go from, we can't in that context substitute Thera for the mother of Thera. That is, the claim is, in a particular context, it may be that one can be substituted yeah. Well, you're right. I've formulated the condition without a crucial quantifier. And the crucial quantifier is what A equals B licenses is substitution from P of A to P of B and vice versa, no matter what the frame is. That's the quantifier. It's for all primary occurrences. Here it's going to be extensional equivalences. The symmetric intersubstitutability is quantifying over all argument frames. So it would have to be that Thera's mother was substitutable for Thera in all contexts, but not vice versa. And I'm going to explain why that isn't true later on. But you see that it isn't true, that though there's some context, being older than, well, now I'm actually losing track of the example because we didn't have an identity there. Oh, you were saying, yes, for being born before a certain time. Yeah. Well, then being born after it is going to be, after that time is going to be a context in which you can't substitute asymmetrically the one for the other. So if we think about the substitution licenses, then the claim is the substitution license that says in any context in which one of these terms occurs, you can substitute the other, saving our favored semantic property, truth, or goodness of implication, as you like. And the claim is that's true universally. Right. That's the form of the substitution license. And you're saying, well, but in addition to that, aren't there some one-way asymmetric licenses? And the answer is yes. For restricted contexts, there are, but not for all the occurrences. Whereas for the predicates, we can look at they can have asymmetric relations that hold no matter what the singular terms are. So from walks to moves is good no matter what's walking or moving. That's the corresponding condition. So, I mean, I don't know if this is clear if we think about yeah, okay. So this is a very general claim about the difference between, in the text I call these simple material substitution inferential commitments. The ones that govern singular terms are going to be made explicit by identity claims, which are going to license intersubstitution in any extensional, any primary occurrences. We're not going to worry about the intentional occurrences paradigmatically inside propositional attitude descriptions. And the program is to make sense of singular terms in terms of their primary extensional equivalences, occurrences first, and then we'll tell a story. And I actually gestured 2 weeks ago at how that story might go, the different substitutions in de re, which are extensional, and de dicto, which are not, but sort of extensional at one remove of social perspective. So the substitution inferential commitments that govern reasoning with singular terms are de jure symmetric and are made explicit by identity claims. The substitutability of one predicate for another are made explicit by quantified conditionals. But again, wherever one predicate appears there, the other predicate can be substituted for it. But those are not always reversible. They can be, but here's a further quasi-empirical claim. Every predicate is involved in some asymmetric inferences. So even though we might have a synonym for walks. The fact that moves follows from walks and not the other way around, that's essential to those predicates. Well, here's an answer to the question, what are singular terms and what are predicates? It's got two parts, a syntactic part and a semantic part. And the syntactic part is singular terms are substituted fors relative to sentences as substituted ins, and predicates are sentence frames or remainders. So syntactically, you've got three roles things can play. Sentences are playing the substituted in, singular terms are substituted for, and the substitutional remainder or frame, the sentential frame or remainder, that's the complex predicate. And semantically, singular terms are governed by universal, by substitution inferential commitments that license the universal symmetric intersubstitution of two terms. Whereas all predicates are involved in asymmetric substitution inferences. They may have some symmetric ones too, but they all asymmetric ones. So from a substitutional point of view, we've got these substitution structural roles and these substitution inferential roles, and between them, they pick out singular terms and predicates as we're used to them. So if we're going to ask the question, why are there any? We can ask that question in the form, why do these roles line up the way they do? Why is it that what's substituted for is symmetrically substitution inferentially significant, and the substitutional frames are asymmetrically substitution inferential? Sorry, Nikki.
I'm only half sure that this is a sensible question. I guess the question is, I know you have an argument for this, but what is it? Can we say, like, as soon as we bring in definite descriptions, it seems to me true to say that every singular term is also involved in asymmetric substitution relations, because we can substitute it with a definite description, or co-refers with a definite description that just happens to co-refer. That Bob Brandom is the coolest person in the room, but the coolest person in the room will not always be substitutable to Bob Brandom. But that seems like a conjuring trick of some sort. Or it's not the same way in which predicates are always involved in asymmetric replacement relations.
I mean, what matters there is not that you picked a definite description, but you picked one that has an indexical in it.
Right, yeah, so indexicals are the culprit. Yeah.
Oh, okay, so I'm not talking about that.
Okay, great.
I mean, in fact, what I'm discussing will work for term token repeatables. Now, we need to do all this with term token repeatables that are that consist of all of the cotypical tokenings. So for canonical proper names, all the tokens of that type are supposed to co-refer. I mean, in fact, are there any such? Good question. And we're working as though we have expressions like that. To do indexicals, we have to drill down one step further and look at how different tokenings are related as being the same, as being tokenings of, in the semantic sense, the same term. And there, the asymmetric anaphoric relations are crucial. That is, there's, stepping slightly farther back, so we're descending from the inferential level of semantics to the substitutional level in order to get below sentences. In order to get to tokens rather than types, you need to go one step further and look at the two kinds of structures of token repeatables. One of them that's a symmetric equivalence class of all the cotypical tokenings, and that's what we sort of pretend we're dealing with for arguments like this. But then we have to see that the very same role, for instance, flanking identities, that can be played by, in effect, term types, can also be played by anaphoric chains of them. And that's how expressions like the room are going to get dealt with in terms of what we need still to be able to consider identities that go across this, but it's going to have to be an anaphoric dependent of this room that figures in that expression. I do want to get to talk about these token repeatables because they're another instance of this structure. I just mentioned that if we think about the substitution inferential semantic significance of things, we see, well, they come in two flavors, symmetric and asymmetric. Well, we've seen that before. Reason relations come in two flavors, a symmetrical one, incompatibility, and an asymmetrical one, implication. Well, the subsentential expressions also come in two semantic flavors, one of which involves symmetric intersubstitutability, and the other of which essentially involves asymmetric substitution. Well, when we drill one step further down and look at the ways different tokenings can be tied into the things that stand in substitution inferential relation, we find there's a symmetrical one, all the cotypical tokenings we get in equivalence class, and there's an asymmetrical, usually temporal, though not always anaphoric and run backwards, anaphoric chains of these things. Why do this binary of a symmetric and an asymmetric component, why do these keep getting repeated at every level of the structure? This is something we'll have something to say about next week as well. So anyway, that's a reason I'd like to get to talk about that, and maybe we will. But what we've gotten from this substitutional analysis, an answer to the question, what are singular terms, what are predicates, is a definite answer in terms of substitution structural role and substitution inferential significance, but it gives us a set of possibilities to consider to ask the second question. We ask, well, why are there any? The possibilities, the four possibilities, and this is over the top of page 2 of the handout, it could be that what's substituted for is symmetric and the substitutional frame is symmetric. Or it could be that what's substituted for is asymmetric and the substitutional frame is symmetric. It could be that what's substituted for is asymmetric and the substitutional frame is asymmetric. Or it could be that what's substituted for is symmetric and the substitutional frame is asymmetric. That fourth alternative is the one we see with singular terms and predicates. So, a way of asking the question, why are there singular terms and predicates? Why does subsentential structure take that form? Is to ask what's wrong with the first three alternatives. And I said, well, what's wrong? What do you mean, what could be wrong? Well, can we show that a language that had subsentential structure of one of those three kinds would be expressively impoverished in some fundamental way relative to languages that had subsentential structure of this other kind? Is there some expressive impoverishment that necessarily goes with any other way in which items playing substitution structural roles of a certain kind are semantically significant, the kind of substitution inferential commitment that governs their use. So we have a budget of possibilities here, and the possibility of an argument if we can see some sort of expressive impoverishment that any language that had this other arrangement would have. And we have a paradigm if we think about the first one. If both what's substituted for and the substitution frames we get are of de jure symmetric substitution inferential significance, then you can't, in principle, use those to codify asymmetric implications that the sentences are involved in. They just won't help you. You won't be able to derive the one-way inferences from Thera walks to Thera moves. There won't be any way to build that out of. You won't be helped in codifying those implications if both the substituted fors and the substitutional frames are de jure symmetrically significant. Then they can only codify symmetric sentential implications. The asymmetry of the sentential implications has to be rooted in asymmetric relations between one or the other of the items. Now, that's compatible with both of them being asymmetric, since the asymmetric ones can have symmetric. That would be option 3. Or the one that's actually the flip of what we see, where what's substituted for is asymmetrically significant and the substitution frames are symmetrically significant. Nonetheless, what 2 and 3 have in common with each other and what distinguishes them from 4 is that the substituted for is taken to have an asymmetric substitution inferential significance. So if we could argue that some fundamental expressive impoverishment necessarily went with that way of lining up the syntactic substitutional roles and the substitution inferential significances, then we'd see why, if you're going to distinguish subsentential structure, it's going to have a singular term predicate structure. And that would be an answer to the question, why are there any singular terms? That's a good place to have a break from my story. So why don't we have a bit of an early one here and come back. It's 2:11, so let's come back at 2:26. Okay, so let me review the bidding a little bit. We said Frege gave us the idea of using a substitutional scalpel to dissect sentences into semantically significant subsentential expressions. And if we look at that substitutional apparatus from a syntactic point of view, we see that we get two kinds of subsentential semantically significant things. The substituted fors, which we understand in terms of the relations among substitutional variant sentences, and the substitutional frames or remainders of the substituted in sentences. And we said syntactically these are of different characters. What's substituted for is really a part of what's substituted in. But the substitutional frames or remainders are better thought of as patterns in them. And I suggested that we think of them as equivalence classes of sentences, each of which can be turned into any one of the others by substituting for some of the expressions in it. And these are what I was talking about earlier as complex predicates, not just the simple predicates. So singular terms play that substituted for term, and predicates, complex predicates, are the sentence remainders or the sentence frames, the equivalence classes of sentences with respect to substitution. And then we say, well, we wanted semantically significant subsentential structure. That means we've got to have information about the implications that the sentences stand in, codified somehow by seeing these subsentential expressions in them. Why do we want to do that? Well, the thought is that we master the inferential roles of all sorts of complex sentences that we've never heard before because they're put together out of pieces that we know the conceptual content of, and we know the ways of putting them together, and so we can put new bits, familiar bits, together in familiar ways, but where we've never put those particular bits together in that familiar way. But if we can, from that, compute at least the core implications that something's involved in, that tells us how we can have some grip on the inferential role of sentences that we've never heard before. It's because we've heard all the pieces of it, and we associate contents with that. And though those contents might not suffice to generate all the implications, if it turns out, it might turn out that you could understand the word brown as well as it was possible to understand it, and the word cow, and still not be able to deduce from that all and only brown cows are dangerous. That isn't true, but it could be true. And there's no reason to think that if it were true, it would be derivable from your understanding of brown and of cow. New stuff happens, you get new classifications. But you're going to know some things about a cow when you know it's brown. You know it's not a reptile. You know that it's not purple. You get some handle on the implications of the sentence from the term, the subsentential expressions that occur in it. But that means there must be some systematic relation between the occurrence of the occurrence of the subsentential expression in the sentence and the implications the sentence is involved in. And I say, well, luckily there are. There are substitution inferences. For terms, if you think about the one premise inferences that go from P of A to P of B, that go from Benjamin Franklin did this to the the first Postmaster General did this, that holds no matter what this is. That is, no matter what sentence in which the term Benjamin Franklin occurred, you're being told, well, one thing, if you know that Benjamin Franklin is the inventor of bifocals, then any sentence that has Benjamin Franklin in it is going to imply a corresponding sentence, one that's just like it, except it has inventor of bifocals instead of Ben Franklin, and vice versa in that case. And similarly, the sentence frames are governed by substitution inferential significances that say no matter what term the predicate walks applies to, it'll follow from that moves applied to the same term is a consequence of it. But those relations can be asymmetric, and indeed need to be, so that we can generate some asymmetric sentential ones. But it's crucial for those substitution inferential significances of the occurrence of subsentential expressions that they have those big quantifiers in them. That is, no matter what sentence in which the term Leibniz has a primary occurrence, you can substitute for that term the inventor of, the writer of the monadology, and that'll be a good inference from the Leibniz claim to the monadology claim, author of the monadology claim, and vice versa. And in the predicate case, similarly, you're quantifying over all the terms that you can plug into it. You say no matter what the predicate walks applies to, the predicate moves applies to the same thing. That is, the inference to moves is good. But in that case, you can't go round. So that lines up a substitution structural role that something can play, substituted for, or the substitution frame, and symmetric or asymmetric substitution inferential significance if we think about the inferences that have one premise and one conclusion, and the conclusion is a substitutional variant of the premise, either substituting singular terms for singular terms or the whole sentence frame for the whole sentence frame. It's got to be the complex predicates that we look at. So why that arrangement? And that's what gives us our budget of 4 alternatives here. We saw the one that assigns both what's substituted for and the substitution frames. Symmetric substitution inferential significance is a non-starter because it'll never generate any asymmetric implications at the level of sentences, and that's mostly what we've got. So we'd get no help from that one. And I suggested that the key to focus on what's wrong with the other two is that they both give asymmetric significance to what's substituted for. And so the question is, can we see what's wrong with that? And here's the general form of the argument. We have those quantifiers in the substitution inferential significance, the generality that's crucial for our being able to apply these things in new cases. No matter what the sentence frame is, the inference from applying that sentence frame to Benjamin Franklin, the inference from that to applying that same sentence frame to the inventor of bifocals, that's going to be a good implication, no matter what context you put that in. And so here we ask, well, what's wrong with an asymmetric substitution inferential significance for what's substituted for? And we imagine, well, suppose we have two singular terms, A and B. We're using the big PQR for our sentence frames now. What would it mean for A to be less than B as opposed to equaling B? That would be for the implication from P of A to P of B to always be a good one, like the inference from P of A to Q of A when P of A is walks and Q is moves. In this case, it would say, no matter what the sentence frame is, the implication that goes from P of A to P of B is a good one, but not necessarily the other way around. That's what we'd be looking for. Well, what would show you couldn't have that? Well, if every time you give me a sentence frame for which that's a good implication, going from P of A to P of B, suppose I can give you a P prime such that the implication from P prime of B to P prime of A is a good one and not the other way around. Suppose every sentence frame in the language had a converse in that sense. That is, suppose from any sentence frame you could construct a sentence frame that was inferentially inverting in that sense. Well, then there would be no contexts in which A was less than B, in which the one term was asymmetrically related to the other. So we could rule out options 2 and 3 on our list if we had a recipe for taking any sentence frame, any predicate, such that from P of A it always follows that P of B, and producing P prime from which, just because P of B follows from P of A, we know that P prime of A follows from P prime of B, and not vice versa. And there is a recipe for doing that. It's negation. If I'm looking at that, so I don't know if this is visible. Suppose we've got A is strictly less than B. That means for any sentence frame, the implication from, I don't want to pretend that I have conditionals in the language, the implication from P of A to P of B is a good one. And now I say, well, just think about the negations. If the implication from P of A to P of B is good, then the implication from not P of B to not P of A is good. The implication from it's red so it's colored is good. The implication from it's not colored to it's not red is good. Inferentially strengthening, having an inferentially stronger, if P of A is inferentially stronger than B, then the negation is inferentially weaker. And it's not just negation. Putting something as the antecedent of a conditional. If you've got something so that P of A to P of B is good, then look at these two conditionals, if P of A, then Q of C, if P of B, then Q of C, that's going to flip. If P of A implies P of B, then the implication here goes that way instead of the other way, because inferentially strengthening the antecedent inferentially weakens the conditional. Now, these aren't the only ways in natural language to create inverting contexts, but they're the crucial ones. They do give us universal recipes for producing an inferentially inverting sentential context from any sentential context. So, any language that has the basic sentential connectives, negation and conditional, in it, has a recipe for producing an inferentially inverting sentence frame from any sentence frame. And that rules out having substituted fors that are asymmetrically significant, because it's never going to be the case that you can always, in every sentential context, substitute the one for the other, but not the other way around. In half of the context you'll be able to do that, but in the other half it'll go the other way around. The ones that we formed from those contexts using our basic sentential connectives. And furthermore, it's not just a bizarre coincidence that those logical connectives form logically inverting substitutional contexts. They do that precisely because they codify reason relations. And the negation basically flips things from one side of the turnstile to the other, and the fact that the antecedent of the conditional is an inferentially inverting context is just a reflection of its codifying the premises of inferences. You have stronger premises, you get a weaker implication. So that means that first, in any language that has the basic sentential logical connectives, the only form that substitutionally identified subsentential structure can have is a subject-predicate form, in the sense of its being pattern 4 rather than any of the other three patterns that relates the syntactic substitution structural role to the semantic substitution inferential role. Now, you could have a non-logical or a pre-logical language, a base language, that didn't have those expressive capacities. But you couldn't even add that expressive capacity to such a base language unless you either restricted it so you couldn't use those sentential logical connectives to build up more sentences which you could then substitute in. That is, you'd have to just so you couldn't form new predicates using this apparatus. In effect, you can't even introduce the logical vocabulary, sentential logical vocabulary, into a language that has any other substitutionally discerned, semantically significant structure of any different structure than the one that we actually have. And since we've seen that the expressive role of precisely the locutions that produce these inferentially inverting contexts, the negation and implication, is to make explicit, to let you talk in the language about the reason relations. If you have any other kind of subsentential structure, you can't do that. You can't introduce the sentential logical vocabulary into it. Again, on pain of not being able to substitutionally carve up the logically complex sentences, because that's going to screw up your identification of term-like things and predicate-like things. There is a potential counterexample in a mathematical vocabulary. In projective geometry, in addition to particular points, you have general points. And it's crucial to the practice of projective geometry that anything that's true of a general point is true of every particular point, and not vice versa. So in any projective context, in any projective property that holds of a general point, that projective property also holds of every particular point, and not vice versa. How is that possible? I have here a transcendental expressive argument that there can't be a language like that, and yet there it is in projective geometry. No, it's not, because the converses of projective properties are not projective properties. And conditional properties formed from them are not projective properties. You have to savagely restrict the processes by which you can form projective properties from projective properties in order to keep this overall feature of it, that for that restricted set of properties, you can asymmetrically reason from what's true of general points to what's true of particular points and not the other way. And this is actually one of the reasons people gave up on projective geometry. I don't know, it's this is an incredibly serious expressive restriction that is essential to projective geometry, and it meant that it was just better to work in other settings. So algebraic geometry went a different route. You couldn't get there from projective geometry. So I take that, the example of projective geometry, not to be the counterexample that one might have thought, but actually to confirm the diagnosis here. Yeah.
It seems like I have to admit that I didn't quite, I didn't quite understand all the details of the argument we were giving on the board, but it seems like it's crucial to the argument that negation of a predicate is a predicate. And I was wondering whether we are speaking in an assumption here that distinguishes predicates from singular terms. So I was thinking, so I had originally been suggesting over the break that you could, from a language that satisfies for on the kind of, you could get to by a sort of translation manual where if we say that A is read in the original language, in the new language we'll translate is read to be the property of redness, and that's going to be expressed by a singular term, and A is going to be translated to is the property of being instantiated by A. So then we, what we symbolize in the original language as capital R lowercase a becomes in the translated language capital A lowercase r. And now we can't run the argument we were giving on this translated language because when we negate a sentence, we are now no longer creating a complex problem. We would, in the original setting, when we negate a sentence, we create a new predicate. In the new setting, when we negate the sentence, we no longer have the complex property. So if you negate A as red, you have A is not red, and not red is the property. If you translate that now and you negate, it's not the case that redness is instantiated by A. We don't get this, it doesn't quite work out.
Right, well, how are you thinking of the negation as working? Because what's going on here is your ingenious mapping is of simple predicates, not of onto singular terms, not of the complex predicates, not of the sentence frames. And you can see that by thinking about what happens if you, never mind negation, just conjunction in it. What are we to do of P of AB and Q of BC? We have that's in our ordinary syntax. And now we pull out the B from that. So we're getting the sentence frame that is Q of A and then X and R of XC. Now that's the sentence frame, and the claim is anything that was to be, well, any A and B, any T and T prime, such that wherever you plugged T in and got a premise, the conclusion that you got by plugging T prime into that same thing, that followed. That's got to be true for every one of those. And your mechanism, you're going to want to say, well, the negation, you're assuming that applies sort of to the sentences. Well, yeah, because that's the way sentence frames are formed. We've got to be able to build up the sentences using sentential connectives as much as we want, and at any point go in and form a function from it, and then add on more sentential connectives and pull out more, do more substitutions on them to get more predicates. If we're going to get the whole, just syntactically, if we're going to get the whole panoply of sentences. And our substitution inferential commitments have got to determine at least the substitution inferences, that those things are, that the result of those two alternating phases yields. We've got to be able to say what substitution inferences hold. And your procedure replacing the simple predicates with the terms isn't going to, as it were, scale to all these sentence frames. So, I mean, yeah, in a way, this is where the rabbit gets into the hat, is in saying semantically that there's an analogy between a strictly substitution inference that has a substituted in as a premise and its variant with one thing substituted for another as its conclusion, and to assimilate that to one premise inferences where we've replaced the complex predicate, some complex predicate that's exhibited by the premise, with another one, and we say that's a good one. And that's what we need a sort of recipe to do.
Yeah. Your example had relations in it, right?
Yes.
Yeah, I think that's maybe quite already be the point for my time.
Oh, okay. Because the distinction between simple and complex predicates only comes up for polyadic things.
Yeah. Yeah. You can't translate R of A B in an ordinary way in a way that's
Yeah. So look, partly I hope to have inspired a sense of wonder about Frege's achievement. He figured out sort of how to do all this, this distinction between predicates as sentence frames and as parts, the simple predicates that you build things up out of, the relation between predicates as simple bits that you can concatenate and are parts of sentences on the one hand, and complex predicates, which are sentence frames that you get by substitutionally dissecting sentences on the other. He figured out the relation between these and how to recursively compute the inferential roles of arbitrary complex sentences formed from these two kinds of things. But let me say something more about what the conclusion is. So the conclusion is that discerning semantically significant subsentential structure by using a substitutional scalpel, no matter what the semantic property that you're preserving is, whether it's salvo veritate or salvo consequentiae, we can go back and forth between those. But if you use a substitutional scalpel to discern semantically significant subsentential expressions, then you have to give the substituted for expressions exclusively symmetric substitution inferential significance, and the substitution frames, every one of them has to be involved in asymmetric substitution inferences, on pain of crippling the expressive power of the language, in that you cannot even introduce into it the basic sentential logical connectives that have the expressive power of making reason relations explicit. That's why there are singular terms, rather than, well, whatever it is that there is in projective geometry, that you've given up being able to compound properties logically and form arbitrary properties corresponding to complex predicates. You've given all that up in the projective geometry case. But the expressive power is the expressive power of sentential operators. We understood how they worked without delving down below. But it turns out that having that expressive capacity at the sentential level has as a consequence that your it puts strong structural constraints on the subsentential structure that you have. It's got to be a term-predicate structure. Well, what does that mean? Well, look, at the beginning I said, one answer to the question, why are there singular terms, and predicates, is, well, because the world comes in particulars and their properties and relations. And so if we're going to talk about that world, we need terms that refer to particular objects and predicates that have sets of objects as their extensions that characterize the properties and relations of those objects. But I'm saying the question of why the world comes in particulars and their properties and relations, and the question of why language must have a singular term predicate structure, those are two ways of asking the same question. The world comes in objects and their properties and relations because languages are expressively crippled if their subsentential structure isn't of the term predicate sort. This is not just a result about the nature of language. This is a result about the nature of the world. Well, the world insofar as it's discussable in a language that is capable of self-reflection, of putting into the form of claimable statements about the semantogenic reason relations, the ones in virtue of which we can mean anything at all. I think this argument is a transcendental argument for a metaphysical conclusion. Certainly, if you accept the sort of conceptual realism that Ulf and I argued for at the sentential level, then you're just going to see as a reflection of that the world that we're talking and thinking about must come in this shape. But that would be an astonishing conclusion to be able to draw, that by thinking about the structure of the language, we can find out fundamental things about the structure of the world. Well, the structure of my language is the structure of my world, Wittgenstein says in the Tractatus, and that's right, not, that it have Indo-European structure or whatever, but that it have term predicate structure, that's not optional. And the non-optionality of that is the same as the necessity of the world coming. You're welcome to think, maybe not nominally, that's why the phenomenal world has this structure, but that's sort of where Kant came in. This is not at all the transcendental structure of experience that he focused on, but it was the same thought, that there isn't room between the necessary structure of our, for him, experience and the necessary structure of the world. Well, this is a different argument, and it's the language rather than the experience, and yet your story would have to be about how the metaphysics could be quite other, and yet we could think about it as successfully as we do in the only kind of language we could speak. Anyway, the only kind that has semantically significant subsentential structure, words, not just letters, making up the different sentences. So yeah, I think thinking hard about substitution sort of takes semantic inferentialism and logical expressivism to its next level, literally its next level, the subsentential level, and once again thinking about what the abstract structural possibilities are, and as always wondering which of these structures can we relax. Well, the demand that identities always be symmetric, that's a real structural constraint. Could we relax it? Our argument at the level of sentences about almost every kind of structure has been, no, look, we can, there is a way to relax that structure and still keep control of things. Doesn't have to be topologically closed, doesn't even have to be explicitation closed. But here we're finding a structure that is unget-overable. If you're going to impute semantically significant subsentential structure using substitution as our way to do that, as the Phrygian method, there's completely other ways of doing it. But if you're going to do it substitutionally, it is not optional to have the substituted fors be symmetrically substitution inferentially significant, and the sentence frames that result from substituting for those expressions in sentences, each to be involved also in asymmetric substitution inferential relations. Now, this, let me indulge myself autobiographically briefly. This is my favorite argument for making it explicit. And it was when this argument sort of swam into my can as, look, this could be done. That was when I really became convinced that there was something to the inferentialist approach, because before that I had been using it as a way of redescribing things that were familiar in the representationalist semantic tradition. I say, look, I can say that in an inferentialist voice. But here, adopting that perspective showed me something I hadn't suspected, that it seemed to me, I really understood something about singular terms and therefore objects, and about sentence frames and therefore properties and relations that I hadn't before. So I insisted on putting this argument in in articulating reasons, even though everybody immediately pointed out that the subtitle of that was, it's an introduction to inferentialism. This is not an introductory argument. As I say, the 30 steps, I think it is consecutive thought and it gets you to the conclusion, but introductory it ain't. But wasn't willing to leave this out. And as a result, when people who didn't want to read the book, or anyway, not right then, would invite me to talk about it, this was one of my go-to pieces. And so I was able to tell this story when I gave the Hempel lectures at Princeton to my teacher, David Lewis and Saul Kripke, who were admirers of it. I was able to give it at Harvard, and Quine asked questions about it, and at Oxford to my hero Dummett. And in each case I felt this is the best I have to offer, and I got to tell this story to the people I most wanted to tell it to. All the people I mentioned now have since passed from this earth, but I got to tell them this story. I feel I should die happy, whether they did or not. It doesn't really solve the question that inferentialists have to ask, which is, but what are these subsentential expressions really? We're working in the sort of logistical syntactic languages where we have simple predicates and things for terms, and we can show why those expressions have to work the way they do. But sentences, our pragmatic story about sentences is there's something like classes of possible assertings, and we can say what general role those acts of asserting have to play in order to be sentence utterings. They have to stand in reason relations that determines what's an appropriate challenge, what's an appropriate defense, and so on. But sentences to play that role do not need to be strings of words or even strings of letters. There's no reason that creatures quite different from us couldn't communicate by, I don't know, displaying mosaics on their bellies that were swirls of colors and so on, that no doubt had some syntax, but not a sequential syntax where substitution could really be pulling one expression out of a complex expression and literally putting another one in that place. There needn't be any places in the sentences for them to exhibit this structure, and as far as I can see, for them to exhibit any inferential structure, that is, for any inferential structure, I don't see why in principle the sentential sign designs have to have any particular internal structure in order to have semantically significant components, because really the sentence frames are just sets of sentences, and we need some way to think about applying one of them to some substituted in. We need some notion of substitutional variation that will get us substituted fors and substitutional frames, but those can be imputed to the sentence on the basis of its inferential role. So the next question is, how generally can you conceive substitution in order to run this argument? Because that's a question about what does this very strong structural constraint, what does that tell us about sentential sign designs? Does it put constraints on the sentential sign designs so that they couldn't just be numerals, for instance, or sentence letters, or something that has syntactically and lexically no subsentential structure, but which nonetheless is used in such a way that we want to say, looking down semantically at the reason relations, look, you're using these sentence letters in such a way that even though this one, this odor or this visual presentation that is the sentence, which can have some internal complexity if you like, but I'm saying semantically you're using this undifferentiated thing as though it were the application of a 17-place predicate to 13 different singular terms, some of which are repeated in argument places. How would you have to be using the sentence so as to be using it as having a distinctive subsentential subject-predicate structure? That's really a question about this substitutional scalpel that we're using to carve things up. How does that look? Well, in implication space semantics. What is substitution? Well, it's a kind of mapping of the space onto itself, but just what kind? That's sort of the next question. And I revert to the way I put it a minute ago. This is an argument for a very strong structural constraint on semantically significant subsentential structure. But what does that mean about sentential sign designs? If anything, does it constrain it at all? And if not, if this structure could all be imputed just from knowing the implication relations among sentences. Can we define that function that takes us from an implication space representation of the implications and incompatibilities of a set of sentences and lets us impute a specific subsentential structure and say, well, if your implication space models underwrite these implications as good, then they're implicitly imputing to these sentences, they're using them as though they had the subsentential structure that, they recognize 12 different singular terms, and here are the triadic predicates, and here for each adicity are the predicates that there are, and impute to each one of them a subsentential structure that says this, your 17th proposition letter, implicitly has the structure of applying a triadic predicate to two different terms, which can be done in a number of different ways, but this is this one of them. So that's what it seems to me an inferentialist ought to want to do in the service of claiming to understand subsentential semantic significance, how things that cannot themselves be premises and conclusions of implications or of reason relations, nonetheless, the substitutional way gives us a non-metaphorical way of talking about the contribution that the occurrence of some subsentential, expression, feature, makes to the inference, the reason relations of the sentences in which it occurs, to really understand what it is for a term to occur in a sentence. We ought to be able to go from the implications that the sentences are involved in to imputing full subsentential structure. And this argument doesn't tell us how to do that. We need something else to do that. Because this argument starts with a notion of substitution and says, well, at a minimum, there's got to be stuff you substitute in, stuff you substitute for, and the result of substituting for that in that. So that's what I'll talk about next time, without having this kind of I'm not promising this kind of a neat result to pull out of my back pocket. This is what we're working on now. This is how far we've gotten in this program. But to say we don't have it done is not to say we don't know how to do it. And so I'll talk next time about this uncomfortable position where I'm confident it can be done like this, I just can't do it at the moment. Tusha.
In various places, I can't remember where specifically, you've highlighted the distinction between what you call declarativism and descriptivism, right? The idea that sort of not all fact-stating claims should be assimilated into the model of descriptions. In what sense does that not does declarativism not just collapse into descriptivism if we accept this argument? Because it just seems like what we're saying is sort of ultimately, in order to at least have a certain level of expressive adequacy, whatever, a sentence needs to be such that when thought of as having semantically significant subsentential components, those behave like things that we're describing.
Okay. Nothing about this argument turns on the sentences having descriptive content. So, the argument would go through if some of the sentences are saying that P of A of B says that A promised something to B, for instance, would be paradigmatically non-descriptive but declarative sentence. So we're still going to give the same sort of subsentential analysis of non-descriptive sentences that we do of descriptive ones. They're going to be about objects, and there's going to be properties and relations in a very broad sense, broad enough to include normative properties and relations. So there isn't a reductive, there isn't any reductive consequences for those, partly because, for the reading of those sentences, partly because we're actually saying so little about, we need so little from the sentences. If we want to do what I was talking about, sort of the subsequent project, going from an implication-based semantics to an imputation of subsentential structure to all of the sentences, well then the implication-based semantics, that's for descriptive things, at least as far as we understand it, in relation to, say, truth-maker semantics, which has the same thing. So, the concern would bite for that project, but for this one, I think everything can go through. They do need to be declarative sentences because we want to worry about negation and conditionals with them. But declarativizing normative things, like talking about what somebody ought to do, those embed just fine as antecedents of conditionals and negatum. So the argument would still go through for those. Okay. Well, this argument really is epitomized in this handout, in the 30 steps. And what is delicate about it, there is a modest literature of people sort of pushing back against this. And the key point does turn out to be the generalization that's claiming if you're seeing semantic significance for the substituted fors, then it's got to hold for every sentence frame that they can fit in, and correspondingly for replacing one complex predicate with another, one sentence frame with another. That's got to hold for every, as it were, tuple of terms. So that's what's doing all the work in this, and that's part of saying, of unpacking semantically significant subsentential structure, distinguishing these from the it in "it is raining" or the sake in "I did it for her sake," where you can't. One way of thinking about how those words are welded into the idioms that they're in is precisely that you can't substitute stuff for them. I did it for her dog is not the same as I did it for her sake, and so on. All right. Well then, so next time will be something completely different because making it up and not really knowing where it's going, but there are interesting things to be found. Thank you.